Okay, so we are going to be covering the sheet for the perfect square trinomials. So the first part, it wants me to circle all the perfect square trinomials and their factors. So when I first look at this one right here, I can tell that it's a perfect square trinomial because when I take my b value here and I divide it by 2, I would get -4. And then when I take -4 and I square it, it gives me a positive 16. So that is how I know that this one is a perfect square trinomial. This one right here is not even a trinomial, so I can go ahead and scratch it out because it is not what I'm looking for. This right here, this x plus 3 squared, this is the factors of a perfect square trinomial, because what I would have here is actually x plus 3 times x plus 3. So whenever you multiply the same factors to get a product, that product would be a perfect square trinomial. All right, so looking at this one, again, I'm going to do what I did up here before. I'm going to take my b value and I'm going to divide it by 2. So 14 divided by 2 gives me 7. And then 7 squared gives me 49. So I know that this one is a perfect square trinomial. This one right here, even though that they both contain the x and the 5, this minus and the plus sign would not give me a perfect square trinomial. So this one would not be what I'm looking for. But this x plus a times this x plus a would create a perfect square trinomial. Okay. All right, so we need to factor the following polynomials, and we need to draw a smiley face next to each perfect square trinomial. All right, so let's see. What I'm going to do is I'm going to factor this out. So my a is going to be 1, my b is going to be -18, and my c is going to be 81. And since my a value is 1, I do not need to use my box method, so I can go ahead and multiply 1 times 81, or my a times my c, so that gives me 81. And now I need two factors of 81 that will add up to give me -18. So I would use -9 and -9, because -9 times -9 gives me a positive 81, but when I add -9 plus -9, I get a -18. So therefore my factors would be a minus 9 times a minus 9. And since they're the same, I can tell that this is a perfect square trinomial. Okay, let's see. Oh, let's go this way. Number 2. So this time we have 2g squared plus 3g minus 2. So here my a is going to equal 2, my b equals 3, and my c equals -2. And since my a value is not 1, I know that I'm going to have to use the box method on this one. I'm going to draw that out. So in my top left box, I'm going to put my first term, which is 2g squared. And then in the bottom right, I'm going to put my last term, -2. So now I'm ready to do my a times my c, which gives me -4. So two factors of -4 that will add up to give me 3 would be -1 and 4, because -1 times 4 gives me -4, and -1 plus 4 gives me 3. So that's what I'm going to use to fill out the rest of my box. I'm going to put my 4g in the top right, and then the -1g in the bottom left. And now I'm ready to start factoring out. So starting with the first column, I see that they have a GCF of just g, and in my second column, they have a GCF of 2. And in the top row, they have a GCF of 2g, and in my bottom row, they have a GCF of a -1. So therefore, my factors are 2g minus 1 and g plus 2. And since these are not the same, this would not be a perfect square trinomial. Okay, number 3. So the first thing I'm going to do, since I can divide out this 2 because both of these are divisible by 2, I'm going to do that to change my equation. And I'm going to go ahead and write this 2 down here since I'm factoring out. So that would give me the new equation of x squared plus 5x plus 4. So now I have a equals 1, b equals 5, and c equals 4. And since a equals 1, I do not have to use the box method, so I can go ahead and say a times c, which gives me 4. So two factors of 4 that will add up to give me 5 would be 1 and 4. So therefore, my equation would be x plus 1 and x plus 4, and the 2 as well. So those are all my factors for that product here. And since they're different, we can tell that it is not a perfect square trinomial. Okay, so going back up here to number 4. So here again, we're going to do A equals 1, B equals negative 10, and C equals 25. And since my A value is 1, I don't need to use the box method. So A times C gives me 25, and I need two factors of 25 that add up to give me negative 10. So that would be negative 5 and negative 5, because negative 5 times negative 5 gives me a positive 25, but negative 5 plus negative 5 gives me a negative 10. So therefore my factors are C minus 5 times C minus 5. I just have one more after this one. Okay. And since I see that both of my factors are the same, I know that this is a perfect square trinomial. So I'll put my smiley face here. Okay, number 5. So again, I'm going to start listing my A, B's, and C's, or my ABCs. So A equals 1, B equals negative 14, and C equals 49. So A times C gives me 49, and I can go ahead and do that because I don't need to use the box. So now, two factors of 49 that will add up to give me negative 14 would be negative 7, because negative 7 times negative 7 gives me a positive 49, but when I add them, I get a negative 14. So therefore, my factors would be y minus 7, and I'm just going to put squared since I would be listing out the same factor, and therefore this is a perfect square trinomial. Okay, number 6. So again, I have a GCF of 2 here because I can divide 16 and 32 by 2. So I'm going to do that first. I'm going to go ahead and write that down here as part of my factors. So my new equation would be z squared plus 8z plus 16. Okay. And then I'm going to do A equals 1 now, B equals 8, and C equals 16. So A times C gives me my 16, and two factors of 16 that add up to give me 8 would be 4 and 4. So my factors would be Z plus 4, and again I'm going to go ahead and square that. So that would make that a perfect square trinomial since my factors would be the same. Okay, now flipping over to the back. So number 7 says, which of the following would create a perfect square when modeled with algebra tiles? So it's the same idea. We have to have two factors that would be exactly the same. So right away I can see that my answer would be C, because 9x plus 4 squared is the same as saying 9x plus 4 times 9x plus 4. Okay. Moving on. So now we need to determine if the polynomial is a perfect square trinomial or not, and then factor it. So remember the way we do it, and we can actually, on the ones that are a perfect square trinomial, we can use these methods as well to go ahead and find the factors since all of my A values here are 1. So negative 12 divided by 2 gives me a negative 6, and negative 6 squared gives me a positive 36. So therefore this one is a perfect square trinomial, and my factors would be, it's going to be m minus 6 and m minus 6. Okay, so number 9, again I'm going to take my v value, I'm going to divide it by 2, so 16 divided by 2 gives me 8, and 8 squared gives me 64, so therefore this one is a perfect square trinomial, and my factors are going to be s plus 8 and s plus 8. Okay, so for number 10, right away I can tell that this one is not a perfect square trinomial because my b value here is a negative 1, and that is not something that's divisible by 2. So we'll go ahead and have to do our a equals 1, b equals negative 1, and c equals negative 2. So a times c gives me negative 2, and two factors of negative 2 that add up to give me negative 1 would be negative 2, 1. So therefore my factors are x minus 2 and x plus 1. Okay, number 11. So it says Joanne has a square-shaped garden that she would like to enclose with a fence. She knows that the garden has an area of x squared plus 22x plus 121, and it wants us to find the length of each side of Joanne's garden and determine the perimeter. So right away, I know that this is going to be a perfect square trinomial just based on the fact that they told me this garden was a square shape, and a square has all the same sides. So to find the factors, so that I can determine what the perimeter would be, I'm just going to take this b value, 22, and I'm going to divide it by 2, which gives me 11. So I know that my factors then are, or my lengths are x plus 11. So now I'm going to multiply this x plus 11 by 4 because that's how many times I would be adding up x plus 11 to determine what the perimeter was. So 4 times x is going to give me 4x, and 4 times 11 gives me 44. So therefore my perimeter is 4x plus 44. Okay, so now we need to fill in the blanks to create the product of a perfect square trinomial. Okay, so now we have for 12x squared plus blank x plus 9. So all I need to do is take my 9, and I'm going to take the square root of it, which gives me 3. So then 3 times 2 gives me 6, so I know my b value is 6. Okay, number 13, I just need to take the b value and divide it by 2, which would give me a negative 7, and negative 7 squared gives me 49, so I know this would be 49. All right, number 14. So I have to take my c value here and take the square root of it. So the square root of 1 is just 1. And then 1 times the 2 is just 2. So this is going to be 2x here. All right, and last one, we're going to take the negative 16 and divide it by 2. That would give us negative 8. So we're going to take the negative 8 and square it, and that would give us 64. So we're going to put 64 right here. And that concludes our worksheet here on perfect square trinomials.